So in this video, we're going to now start the intro to linear programming, which is one of the ways which you would solve any linear programming question is by using the graphical method. While other videos will focus on other methods to solve a linear programming problem. So this is the intro video, so it will just have the graphical method in linear programming. So to start, there's a question that I'm going to give, which is they say maybe maximize 4x1 plus 5x2. That's the maximizing function. We'll come back to it at some point. Then they give you these other constraints, which they always put as subjects to their constraints. So this one constraint will be this: 4x1 plus 2x2 will be less than but equal to 120. The next one is 3x1 plus 6x2 less than but equal to 180. Then that's so they've just given you those two constraints, and then sometimes you just hear they'll be putting these things at the bottom. What do they mean by these certain components they put right at the bottom? X1 comma x2 is greater than or equal to 0. What they're just telling you is that the values of x1 and x2 that you're going to find, they should not be less than 0, but they should be greater, meaning they should be positive. In short, when they say less than 0, you have negatives. So you should understand that statement. So they say greater, this symbol is greater, this one is greater, meaning they should be positive. Then now what you do before you graph any equation, find intercepts. What do I mean by that? Meaning find the cutting points of this equation. How do you find intercepts? In short, I'm sure this word is very familiar. You once approached, I'm sure, this topic maybe back in your high school linear programming. Intercepts, what we do is that we just make one of the variables 0 and solve for the other variable in the equation. So there's x1, there's x2. So let's say what would be x2 if x1 is 0? That's the first scenario. If this one becomes 0, this one here, then this function that is left here, 2x2 equal to 120, meaning what is the value for x2? If you divide 2 both sides, you're going to get 60. So by the way, this x2 that you're seeing, it's just representing y. It's just that mathematicians also use this as another symbol for y, but it's just like x comma y. X1 is x, x2 is y. So just know the two meanings. They just use them random. That's why even when you're writing your coordinates, it's always x comma y. Something if you remember from your high school, you start with x then comma y. So our x is x1, our y is x2. Then the intercepts are not done. We just made one scenario where this one is a 0. What about a scenario where x2 is a 0? What are you going to do? What will happen? You have the 4 and you have the 120 left. What are the coordinates you're going to be left with? 30 comma what? So this time around x1 will be 30 while the x2 will be 0. So you always have to have two sets of coordinates. In short, for each equation they will see the reason why. Then the next equation is this one at 3x1 plus 6x2 180 is equal to 180. Find the intercepts on that one as well. So I'll bring them maybe to the right hand side of the screen, the coordinates for this other one. So when x1 is 0, let's make x1 0 in this last equation here. What would be the value of x2? So x1 is 0 comma what? The other one will be 30. Okay, what about the other side? Close the other intercepts. Let's say x2 is now 0. What would be the answer? You're now like dividing 3 both sides. This gives you 60 comma 0 because x1 is now 60 while x2 is 0. Then you go and plot. Just remember your coordinates for each equation, then you just go and plot it on a graph. So when you're plotting things on a graph, just find a suitable scale. What do I mean? You've noticed the figures that you have. There's a 0, there's a 60, you have a 30 somewhere. But if you check on the coordinates that were coming this side, the comma what? Let's say there was a 0 comma 60 in the first equation. Meaning which one is your y-axis? This one. As I said, x, this is the one they're calling x2. This is your x1. So the x2 is your y, the x1 is your x. So that's what you just know. So you know, okay, the y-axis, the largest figure that is showing, or no, the y-axis figures that we've been finding, 60 looks to be the largest. So what you're just going to do is you just find a proper scale figure and just say, okay, 60, 40, something like that. Just take a nice random scale. And maybe you're just moving, maybe you're here, we're moving in 20s if you've noticed. Okay, then you can go below here. Maybe you're also moving in 20s, 40. Just have a systematic scale. Whatever progression you're using on the other side, use the same progression also on the other side. Maybe here we can even just go to 8. Although even it, I think randomly it was also ending on like 30 or so, or 60. Yeah. Then we plot. Remember those coordinates, we had 0. Remember there was 0,60 at some point. How do you plot 0,60? 0 in this line, comma 60 there. Just remember from your high school, I used to plot these things. Then the next one is 30,0. It's just here. 30 is here. 30,0, and the 30 is, this is like this. This is the one I plotted. 30,0. There was a coordinate which was like this. How do you plot that one? 30 is representing x. Remember, it's always x, y. So meaning you come here on 30. We have drawn a small line, then comma 0, meaning it's just here. It's not going anywhere further. Then another point that we had, okay, that's 30,0. So these two coordinates that I've plotted were from the first equation, and once you're done with it, just connect the 2 points. That's it. That's what you just do. Once you're done, connect the 2 points. Okay. In the next one, we had the second equation was 0,30. 30 is here. Just here, I've put an x value. So I didn't just cancel that. Okay. So just here, that's your 30. 0,30 goes like this. 0,30. So the 30 is on the y in short. So you come and cut on the y-axis there. Then 60,0. 60,0, meaning you focus first on the y-axis. So always when you're plotting, you first identify x because it's the first one. So you go to 60 here. Now comma what? Comma 0, meaning it's just along that line. Then connect the 2 points because you're also done with the second equations plotting. After that, you can just label them for the sake of identification at all. This line is from the second equation, which was 3x1 plus 6x2. Okay, I'll just want to finish it because of the space. Then this other one is coming from the first equation, which was 4x1 plus 2x2, something like that. Then what you're now going to do is that identify your feasible region after your graph. How do you know the feasible region? Remember the sign that they were using on the constraints was these, the ones that we wrote subjects to. They were using this sign. What do you call it? Less than but equal to. How do you present that on a graph? Just now when they say less than, go below. Okay, they want the region below the line. So let's say this line is here. This line for 3x1. What? How do you plot below? How do you show that they want the region below? Just shade the unwanted region, cancel it out. All this I'm crossing out is not wanted. They want what is below. They want what is actually below that line. So even here, just plot what is below. I mean, just leave a space on whatever is below the lines, which is this white space left, and this is what we would call the feasible region. So just understand the symbols. When they say less than but equal to, they want anything that is below that line that has been plotted, below it. Then you cancel out what is above that line. That's, I think, that an easier way you can get it. Then once you know the feasible region, just label the corner points. It's got corner points. This is corner A. You can just call it corner A. This is another corner point, corner B. Then here is also a point here, C, and here there is D. 4 points. So you just focus on the corner points of the region that you've selected as the feasible region, and then get the coordinates for it. Yeah, just get the coordinates. So have a look at this graph. I'm just trying to erase this so that I can have space for the coordinates to write. So the coordinates that you will end up with are these. Point A is at what point? 0, 0. If you look at the graph, it's just at that point here where there is 0 here, and that's the one we labeled as A. So it's A. If you say A is what? It's 0 and then 0. Basically, it's x1 is 0 and x2 is 0. That's why we're calling that 0, 0. The next point is B. B is 0, 30. 0, 30. That's your B. It was somewhere here on the next corner point here. There was a 30 there. So just remember when you're plotting, so it's x, y, which is x1 representing x and x2 representing y. See? Point C was midway. I'm sure you remember that there was a point where it was cutting like this, point C. It was here on an intersection of 2 lines. How do you get that coordinate accurately? If again you still recall, we solved such using simultaneous equations. That's the only way you can get a point that is midway. It's not on a corner, it's just meeting on intersection of lines. The only way you can get the accurate coordinates that are there, use simultaneous equations. So you're basically just grouping the two equations that were given the verses. In short, just group the equations that were cutting Don't just pick any. They might have four equations, but only two are meeting. So go to those two lines that are meeting. And in this case, we just that we had two equations, hence it's very easy to not even make any error. You just get the two equations and their functions that were there, and then just equate them to their actual figures which they had. This one was 180. This one was equal to 120. The other one was equal to 120. Then you just like solve. You know how to solve is simultaneous. Maybe you want to eliminate x1, you can use the elimination method. You just put 4 there, you put 3 there, you substitute, and you get rid of x1, and then you can even solve for x2. So me, the resulting answer that I had when I did that, I found that this point C, it was actually 20,20. That's the answer I found, 20,20. Then finally D was 30,0. Then what you just do is that test all these coordinates into this function, the z which started, the z function from the onset of the question, 4x1, z is equal to 4x1 plus 5x2, because you're trying to maximize this function. That's why we're going back to it. This is x2. So start substituting x1 as of point A, x1 is 0, x2 is 0. What would be z? 0. The other point here is for b. When for b here is that okay, x1 is 0, that's the first figure there, and x2 is 30. So you put it in the equation, you find that the z that you're getting for this other point is that's for 0,30, right? Yeah, 0,30, it's 150 that you get for z when you substitute. The other one, you substitute both 20s. Both 20s are going to give you 180 when you substitute them again accordingly to their signs. The last one is giving us 120. This one is giving us 120, the last one. So therefore, what are we doing? Maximize. Meaning, what point do we pick? The largest z value, which is 180, which is at which coordinates? You say z, the maximum z we've gotten is 180. At which coordinates? X1 was 20 and x2 was 20. Those are the ones which produce. Because when you're putting them in this function, which we're maximizing, you find that for sure, you substitute x1 there, x2 there, you get the 180, and it was the largest z value that popped up. And that's when you pick, because we're maximizing. If they said mean, go for the lowest. So that's basically in our intro video here.